Hello children, welcome to the Physical Science digital class. Children, now we are in work and energy lesson. So, we already finished the two parts of the lesson. So, whatever the concepts we have discussed in our previous sessions, the scientific meaning of work done, and also we derived the formula for that work done, that is W equal to F into S. Work done is a scalar quantity and it has units in SI system Newton meter and in CGS system ergs, that is dyne centimeter. Newton meter is said to be a joules and dyne centimeter said to be ergs. 1 joule equal to 10 to the power of 7 ergs. And also we discussed about the energy. What is energy? The capacity of an object to do work is known as energy. Energy and work both have the same units, and also we derive the equation for the kinetic energy. What is this kinetic energy? The energy acquired by the body due to its motion. So, when the object have motion means it has some speed, then it possesses kinetic energy. The mathematical expression for this kinetic energy is half mv square. Here m is mass of the object and v is the velocity of the object. Potential energy. Energy possessed by the body by virtue of its shape, size and position. Means when the object is at rest at any position, the object possesses potential energy. And also we discussed about the types of potential energies. Those are gravitational potential energy, elastic potential energy and chemical potential energy. Potential energy. Energy possessed by the body by virtue of its shape, size and position. So, whenever the object's configuration, the shape and dimensions are changes, so it will acquire some more energy. That energy is known as potential energy. We discussed about the different types of potential energies. Those are gravitational potential energy, elastic potential energy and chemical potential energy. What is this gravitational potential energy? Whenever the object is at certain position from the ground, from the surface of the earth, it acquires gravitational potential energy. Due to gravity it happens. So, this potential energy equation is also derived, that is potential energy. Gravitational potential energy is Pe equal to mgh. And also we discussed about the mechanical energy, that is sum of kinetic energy and potential energy. Children, mechanical energy is conserved and we also some more examples are observed in our previous session. How the mechanical energy is conserved means how the sum of kinetic energy and potential energy is constant. So, we already this is proved in the case of freely falling object and also in the case of simple pendulum. Okay children. Now, in this session I am going to explain about power. What is this power? So, I think you might have heard this word from many people, that is power. So, what is this power? Rate of doing work is known as power or rate of transfer of energy. If any person do the work in small time interval, then we can say that he has more power. Other person do the same work but in long time, so you can say that so he has less power. So, the power has a mathematical expression, that is power P equal to W by T. Here the W is work and T is a time interval. Unit of power is joule per second or watts. James Watt, in the name of James Watt, who invented the heat engine. Honor of James Watt, the power unit is named as watt. Watt equal to joule per second. 1 watt equal to 1 joule per second. In CGS system it is erg per second. So, we have some more units children, that is 1 kilowatt equal to 1000 watts. 1 megawatts. What is mega? That is 10 to the power of 6. So, 1 megawatts equal to 10 to the power of 6 watts. Another one unit is there, that is horsepower. So, horsepower is symbolized with HP in lower case. 1 horsepower is equal to 746 watts. These values are very important, children, to convert the value from one unit to another unit. That is, in general the power value comes in kilowatts, megawatts. So, we might have heard these words whenever in news about electricity, power generation. So, when you heard the news about the power generation, you might have heard these words, that is kilowatts, megawatts, like this. So, power has the units watts. Okay, children. So, let us observe this small problem to understand the power formula, children. A man carrying a bag of mass to 25 kg climbs up to a height of 10 meter in 50 seconds. Calculate the power delivered by him to the bag. So, children, here force exerted by the man on the bag is weight of the bag. What is the weight of the bag? That is given here 25 kg. So, we have the formula for the weight, that is F equal to mg. So, substitute the values of mass and g, that is acceleration due to gravity. We know the acceleration due to gravity, children, that is g equal to 9.8 meter per second square. So, substitute these values in this equation, you will get here the work done by this force in taking the bag up by 10 meters is equal to force into displacement. So, what is force? That is 25 into 9.8. So, substitute the values, that is work done W equal to 25 into 9.8 into S, that is displacement, that is height to which the bag is taken, that is 10. 25 into 9.8 into 10. Finally, the product of these three values is 2450 joules. So, this is the work done on the bag. Then what is the power delivered by that man? We know the formula, that is power equal to rate of work. Rate of doing work means power equal to W by T. Observe here, children. Power delivered by the man P equal to W by T, that is 2450 by 50, which we got in the above calculation. Now, the answer is 49 watts. So, do not forget writing units, children. Units are very important. So, here the power delivered by the man, it is calculated in watts. Try to calculate in horsepower, children. So, we have the value, that is 1 horsepower equal to 746 watts. So, by using this value, try to calculate that value in terms of horsepower, children. This is the task for you and show to your teacher. Now, children, energy. Energy is conserved. Energy has so many forms: heat energy, light energy, and sound energy, wave energy, chemical energy, whatever it is. The total amount of energy in this universe is constant. Means the total value is constant means what? Energy can neither be created nor destroyed, but it can transform from one form to another form. That means we already discussed about this, that is energy transmission from potential energy to kinetic energy, like that. In those process, the energy continuously changing its formation. For example, the light, electric bulb, electricity is converting into light energy, like this. The energy transmission takes place in every process, but the total amount of energy in this universe is constant. So, this is known as conservation of energy. Energy can neither be created nor can be destroyed, but the transformation of one form into another form can be possible. The total energy in this universe is constant. Children, try to observe the process which are happening surrounding you and observe those process and observe that how the energy transmission is taking place. So, let us try to take those examples, children. I think you might have know about this photosynthesis. What is this photosynthesis process? Yes, the plants takes the solar energy from the sun and water from the soil and convert into the chemical energy, that is food, converting into the food, that is leaves, fruits and flowers. So, means in this photosynthesis process, energy conservation takes place, at the same time energy transmission takes place, that is solar energy to food, that is chemical energy. So, solar energy to chemical energy. The next example is sun. Inside the sun, what happening? There is a nuclear energy. This nuclear energy converting into heat and light energy. Our body, means when we take food, that is nothing but the food has a chemical energy. That energy converting into mechanical energy, that means to do work. To do work, this energy is utilized. Formation of fossil fuels. Children, you know about this, that is what is fossil fuels. So, whenever the plants and animals are dead, so they buried under the soil, and after a long period of time they convert into the petroleum like LPG, means these are known as fossil fuels, that is chemical energy into chemical energy only, but here the biomass of the tree and plants and animals is converting into the fuels. So, these are the natural process taking place in the nature. We can take some more examples in our day to day life. Tell me children, in electric fan, to which form it is converted? Electricity, that is electrical energy to mechanical energy, means whenever you switch on the fan, you have to give the power supply. Then what happened? Yes, the fan will rotate. Rotating means what? Nothing but mechanical energy. Heater, here also electrical energy converting into thermal energy, that means heat energy. Electric bulb, electrical energy converting into, yes, light energy. And yes, home theater, you know about this home theater. So, in loudspeakers, what happens there? The electrical energy converting into sound energy, electrical signals converting into sound signals, that is. So, these are the examples which are happening in electrical appliances. Some more examples, electric motor. Do you know about this children? Electric motor. What is electric motor? So, electric motor is generally observed in various appliances like grinder, in fan and in some agriculture field also, that is electric motor. What is electric motor? Whenever the power is supplied to that electric motor, it rotates, means what? Electrical energy is converting into mechanical energy. Hydroelectric power plant. What is hydroelectric power plant? Whenever the water flows, so it rotates the turbines. From this, if you connect it to a generator, then electricity is generates, means here hydro power is converting into electrical energy, means mechanical energy is converting into electrical energy. Vehicles, bike, car, so any vehicle, we fill the tank with petrol or diesel. So, what are these petrol or diesel? These are the fuels, these are the chemical energies. When you run the vehicle, this chemical energy convert into, yes, mechanical energy. Heat engine, what is this heat engine children? Heat engine means heat engine converts thermal energy into mechanical energy, means whenever the hot water or steam flows in the path of the flow of the in the path of the flow of the steam, when we arrange the turbines, it rotates the turbines, means what? That heat is converting into the rotational energy, means mechanical energy. So, these are the day to day life example children. Okay children, we have energy, non-renewable energy and as well as the renewable energy. So, non-renewable energies are coal, petroleum, LPG, means fossil fuels. So, how the fossil fuels are formed? Yeah, due to heat, high pressure, absence of oxygen and action of bacteria, the dead plants and animals decomposes over a long period of time, that is millions of years, get converted into fossil fuels. Fuel release energy on combustion children. So, due to this reason, this fuel is used in vehicle industries in so many areas. So, how these fossil fuels are formed? From the sun, the plants receives the solar energy, and not only the plants, animals also receive the solar energy, but at the same time the plants convert this energy into food, and this food is taken by the animals and human being, and after death of these plants and animals, it is formed as a fossil fuels after thousands of years, and this fuel is utilized to generate electricity and to run the vehicles and to run the machines. This is about fossil fuels. But children, whatever the fossil fuels are there in our earth crust, and those are not enough for thousands of years. After some years, the fuels are going on reducing. So, globally, we currently consume the equivalent of over 11 billion tons of oil from fossil fuels every year. If we carry on as we are, our known oil deposits could run out in just over 53 years, and gas reserves only gives us just 52 years left. Coal deposits could be gone in 150 years. So, when these fuels are run out, then what is the next? How to run the vehicles, how to run the industries, how to produce the electricity. So, what we have to do? If you are not avoiding this fuel usage, so the scientists and the industrial people looking at other side. What is that? That is renewable energies. What are those renewable energies? Solar energy, biomass, biogas, energy from sea, geothermal energy, atomic energy. So, what is this biomass? Children, see here, biomass means it is a dry waste of plants and animals. Okay, when we remove the liquid from this, whatever the dry waste is there, that will be the biomass. Forest crops and residues, and also agriculture crops and residues, sewage, industrial residues, animal residues, and municipal solid waste. So, from these all we will get the dry waste, and this is the source of biomass, and this can be used as a fuel. And the next one is biogas. What is this biogas? You might have seen this type of plants in your village, children. Mainly this biogas consists, so it is mainly produces from cow dung, sewage, crop residues and vegetable waste. It contains 65% of methane, which is used to cooking purpose. The slurry obtained after usage of biogas used as a organic manure, and which is rich in nitrogen and phosphorus. See children, before going to next source of energies, I am going to explain you what is generator. A copper wire wound on a coil, when you rotate the coil in a magnetic field, it produces electricity. Electricity is induces. We have tidal energy. That means when you place the big turbines inside the ocean, whenever the tides occurs, those tides run the turbines. When the turbine rotates, then what happens? Yes, it is connected to the generator, and in that generator the coil rotates and electricity is generates. Geothermal energy. Geothermal energy means at some places inside the earth soil, so inside the earth, so there is a high temperature. So, high temperature means whenever you compress the cool water inside to that place, then what happen? This cool water converting into the steam because of high temperature. So, we have the water has a boiling point 100 degrees Celsius only. Whenever the temperature is more than 100 degrees Celsius, the water is converting into steam, and this steam, this high pressure steam and hot water running through a atomic number barium and 36 atomic number krypton, that is means 56 and inside the barium and 36 protons inside krypton. So, the remaining neutrons are left in, that is again 3 neutrons are produced. Again these 3 neutrons collide with the another uranium nucleus, and then again it produces the lighter nuclei as well as 3 again more neutrons. In this process a large enormous amount of energy is released. This is known as nuclear fission. This is known as nuclear fission. So, whatever the energy is released, that energy is in the form of heat energy, children. That heat energy is utilized to convert the water into steam, and whenever this high pressure steam is used to rotate the turbines, then simply the electricity can be we cannot control this process. It is happening inside the sun core. So, nuclear power plants are in India. So, there are so many places are there, nuclear power plants are established, that is in Maharashtra, Tarapur, in Rajasthan, Rana Pratap Sagar, in Tamil Nadu, Kalapakam, and we can observe these things daily life, children. Okay. In this session we have learned so many concepts. So, in the next session we are going to discuss about some more interesting concepts, children. Until then, thank you.